I read something somewhere, some little sentence that said, I'm not trying to understand the mystery anymore, I'm just trying to have a relationship with it.
That's right.
So it clicked me into a whole different place.
Well, you know, this is not merely the stoned ravings of the psilocybin brigade. Do you all know, or have you ever heard of Gödel's incommensurability theorem? This sounds daunting and disturbing. Have you ever heard of this? Does anybody have a clue what I'm talking about? Okay, well, that in itself is a measure of the kind of society we're living in, because to my mind, more important than Einstein or Schrödinger or any of those people was Kurt Gödel, German mathematician. And he began by studying the calculus, and he had a very funny method. What he did was he would number every operation in a partial differential equation. And these numbers are called Gödel numbers. G-O-umlaut-D-E-L, Kurt Gödel. And what he showed, and I think this is maybe the most important intellectual step taken in the 20th century, he showed that any formal system will produce true statements which are not provable within the confines of the formal system itself. Now, what this actually means is that mathematics can fail. It means that there is no closure. He proved this logically, showed that closure is impossible, that everything, he showed it for arithmetic, the most secure of all intellectual edifices. Essentially what he showed was that 2 plus 2 equals 4 is a very strong tendency, not a law. And this incommensurability theorem means that no program of formal analysis will ever completely exhaust its subject. There will always be a residuum of mystery. And we need to come to terms with this. I mean, it's taken us 80 years to get Einstein under our belts. And that's a simple notion compared to what Gödel is saying, because what he's saying is not about, you know, the distortion of space-time near massive objects, but something which actually affects our own lives on a day-to-day basis. And, you know, if you live for closure, you're beating your head against a stone wall, and your head will wear out long before the stone wall will. There's a kind of an appreciation for the mystery needs to replace the attitude that the mystery is an unsolved problem. Mysteries have no relationship whatsoever to unsolved problems. Yeah?
I'm just wondering about the motivation of the explorer going into the dark continent, wanting to draw a map of the river, so that you can eventually build a railroad, et cetera, et cetera. You go through a lot of pain, a lot of difficulty as a pioneer to get the map back. If your primary assumption is that this map will never be drawn completely, where's the motivation? What does it then become?
You don't need a complete map. I mean, I'm not such a fan of Wittgenstein, but he seems to have raised his ugly head here. Wittgenstein used to say, we do not seek statements which are true. We seek statements which are true enough. That's this genuflection to the incommensurability theorem. That's as good as it gets, folks. True enough. Beyond that, there's just, you know, the airy realm of metaphysics, which will never be plumbed. So what we're trying to do is refine our model, make it more responsive to what we want the model to tell us. But you don't want to confuse the model with the phenomenon being modeled, because it will always have dimensions which exceed the grasp of the theory.
Well, that's what the probability of Zalman says, that there's a tendency for a particular state to exist. That's as good as it gets.
Yes, although I have real problems with probability theory, which we'll probably get into tomorrow. I think that in a sense probability theory has made it almost impossible for us to think clearly about anything, because it contains certain insidious built-in assumptions that are purely assumptions. For instance, probability theory tells you that when you flip a coin, the odds of it being heads or tails are 50-50. If, in fact, that were true, the coin would land on its edge every single time. So what we need, you see, is not a theory of what is possible. That's science. If you want to know if something is possible, you find a scientist, and they're always perfectly happy to fulfill this function and tell you whether this is possible or not. What we completely lack as a civilization is a theory that explains to us how it is, out of the vast class of possible things, certain things undergo what Alfred North Whitehead called the formality of actually occurring. We have no theory. I mean, science can say, well, it's probable that it'll be this, but it's also 40% probable that it'll be that. You say, well, which will it be? You say, well, I just told you the probabilities. Say, that's not good enough. I want to know. Say, we have no theory of selecting among the probabilities. The other problem that haunts probability theory is that it assumes that time is an absolute flat plane. It assumes that no physicist tells you in his lab notes, please perform my experiment on Tuesdays, Wednesdays, and Saturdays, because it won't work any other time. In other words, the assumption is made that the experiment will produce the data predicted by theory no matter when the experiment is performed. In other words, it's assumed that the phenomena is time independent. But that's just an assumption that Newton got into. Proving that phenomena are time independent is absolutely beyond our intellectual reach. It can't be done. A curious thing about probability theory is, say you want to know how much current is flowing through a wire. Here's how probability theory finds out. It measures the current flowing through the wire with a meter. It measures it 1,000 times. It takes those values and adds them together. Then it divides by 1,000. Then it tells you this is how much current is flowing through the wire. You look at the value they've given you and you say, but we took 1,000 measurements and we never got this number. Say, well, that's because, you didn't average the probability. And, well, if we took 1,000 measurements and not one is the value you're offering, why should we believe that this is the amount of current flowing through the wire? Well, then there's a bunch of hand-waving and epistemic foot stamping and so forth. Science is an incredibly fragile edifice, which if it weren't for its ability to hand its findings on to technologists who make pretty things, it would have to take its place somewhere to the left of, homeopathy, acupressure, something like that. In other words, it is not a meta-theory. It has not got truth by the jugular. It has a bunch of fishy mathematical formula which it's flailing you with. But I think that serious revision of probability theory is going to have to take place.
I think you've given probability theory much more than is really there. Inherently, what it's all about is simply acknowledging the fact that there are variables in anything that we can't know, and we don't know. It's really nothing more than that.
Which brings you back to just the access to the present moment.
Well, but for instance, if the odds that the coin comes up heads or tails are 50-50, why doesn't it land on its edge every single time?
I don't see how it's related to landing on its edge. It's simply what happens with a coin, where it ends up lying, basically, whether it's face up or down, right?
Well, another thing probability theory says is that chance has no memory. And so they always, in first-year statistics, they say, if you flip a coin and it comes up heads 49 times, what are the odds it will come up heads the 50th time? The answer is 50-50. But any gambler would tell you that, if it comes up heads 5 times in a row, bet on heads, for crying out loud. So there's something...
I'm not an acolyte of probability or statistics, because I think a lot is done or inferred from them. It just doesn't exist. I agree. At the same time, really all that's at the basis is the notion that there are things going on here that we can't know, even though that's not acknowledged by most people who are practicing it. That's the reality, probability of statistics.
But don't you think the other assumption is that time is a non-inputting, it's not variable? That you don't say the odds of the coin coming up heads or tails are 50-50 in Canada, but 48-52 in Bolivia.
That's one of the variables that's sort of smeared out simply because it can't be characterized the way people who are doing that like to tend to characterize things. But underlying the whole thing is still the notion that you're dealing with unknowables. And I'm not saying that those who are deeply immersed in practicing probability and statistics hold this view, but the reality is underlying, the sort of underpinning the whole thing is the notion that there are things going on here that we can't know.
Oh, well, I don't have any trouble with that. I understand why science latched on to probability with such a vengeance. It's because, thanks to William of Ockham, there is this notion called Occam's razor, which is this idea that is most simply stated as hypotheses should not be multiplied without necessity. So since the idea that time is a flat invariant is the simplest assumption, try it first and see if it works. But I maintain that, science has, in certain areas, been very slow to make progress in the social domain, in econometrics, in the multiple body problems and stuff like that. Well, I think this is because this simple assumption that time is an invariant has to be re-examined. I would offer a new definition of science. Science is that field of human endeavor which studies phenomenon so crude that they are time invariant. The hydrogen atom cleaves from the oxygen atom the same way every time. But love affairs don't come apart the same way every time. Bankruptcies don't occur the same way every time. These are complex, compound phenomena that are then influenced by the temporal variables and the variables embedded in the environment around them. Now, the problem is, these are the things we're interested in. Love affairs, bankruptcies, and the establishment of empires. Very few people have a passionate interest in the dynamics of the water molecule.
Except that that equipment over there was produced by those notions, these notebook computers, the software that you're running.
Oh, now I know I have you on the run because this is a, but it makes pretty things argument.
No, I'm just saying, I'm not commenting on the value of it or not. I mean, each person has to assess that for himself.
Well, see, I think science is a great enterprise and noble, but not the arbiter of truth.
No, I'm not arguing.
There are no arbiters of truth. The truth of the Tarot, the truth of quantum physics, these are truths in the supermarket of truth. But there's no top end to that process. There may not even be one truth.
But one truth you go out
In a given situation. If you're flipping coins, probability theory is probably a good guide. You wouldn't want to run your love affair on probability theory. So you have to choose the domain. You have to recognize the applicable models, the applicable tools for whatever domain you're looking at.
We're not allowed to do that in culture. We decide the overarching truth for those.
Well, you're allowed to be a heretic. You just don't get paid well. That's the price you pay for that.